Okay, let's start. First, we've got a semicircular piece of paper. Radius 10, folded such that VA touch VB. So we've got our point V at the top and our point AB that meet each other anywhere along the circumference. Yes, Akira? Hurry. So AB will be anywhere along the base of the cone. Now, first find the base radius of the cone, meaning this radius. Okay, so this distance you have to be aware. It is not the same radius as this piece of paper. There are different things. So how are we supposed to identify the radius for this base of the cone? Well, it has definitely got something to do with the circumference of the base. This radius of the cone is related to the circumference of the base area or of the base circle. So where did that circumference come from? This red line. It was formed by joining points A and B together. Let's go back to our semicircle, A and B. If you were to join points A and B together, you will end up with this red color line as our base of the cone. Can you visualize that? Just to check, who can visualize the red color distance on the semicircle AB actually is the same base of that cone? Who can visualize that? Raise our hand. Can visualize? Raise our hand really, really high so that I can be convinced. So Arisha cannot see. Can see now? Raise our hand. Jermaine, can see now? Can you see that the red color distance AB is the same as the base of that cone? Hey, Samuel, be careful, your iPad might drop. Anybody got scissors? I see one people here. Anybody got scissors? Let me. I try and cut it out. Anybody got compass so that I can draw a circle? Anybody? Oh wait, never mind. So whoever is watching the video doesn't know what's happening, don't know what we are doing in class. I mean, this is recorded, ma. Some of your friends are on Zoom. Sorry. Okay, let's use the visualizer. Okay, so here is our semicircle. Same semicircle. In a while, I'll show you on the visualizer. I indicate the points B, A, and B. Okay. Oh. Wow. This is very bad quality. Oh. Okay, I have no idea why this visualizer is so lousy. But anyway, semicircle, just focus on the arc that I actually highlighted in orange that you cannot tell. I'm going to join the two bottom points together, A and O. It's coming back. Oh no, it's dying again. A and B, we're going to join them up. This way. You got a phone. See? Okay, very small, but like this now. Then you see when I open it up. Sorry, the paper very small. If I were to open it up, together, semicircle. Okay, join up again, again. They form the slant height. You see the radius of this original semicircle actually join to form the slant height. And then the base of this semicircle, this circle, was the highlighted part. Right? That's half of the circumference of the original circle. It went on to become the base circle circumference. Okay, anybody wants to see? Anybody wants to go to it for Popo? I just pass down. Okay, so that was that, and now we're back to the notes. Okay, so to find the base radius of this cone, we have to recognize that the rate distances are the same. Let the radius be r. Okay, so we're talking about this portion r. This 2 pi r, the red color circumference of the cone is equal to the distance, the arc length of that semicircle, which is given by half times 2 pi. The radius this time will be 10. So what we have just done is to form an equation. Left-hand side equals to right-hand side. Okay, this part so far? Okay, now the next step is to start cancelling. Hey, we see some common factors, right? Pi and pi can cancel. If you don't cancel away the pi, then use calculator to press. You're going to end up with an irrational number over here, point something. So many decimal places. And then another one on the right hand side, point something, so many decimal places. Do you think you'll end up with an exact answer? So that's forward planning. You are not going to end up with exact numbers for the value of the new radius if you evaluate. So what you can do is pi and pi same, positive number, divide. Then we've got 2 and 2, cancel away, leaving us with simply r equals to 5. So as you pass the paper around, Harry, don't hold the paper. As you pass the paper around, you realize that the radius of that semicircle, which is 10, versus the radius of this cone, it has a value of 5 cm. You form a smaller circle for the base of the cone from a bigger semicircle with a bigger radius. Okay, now then the volume of the cone. How to find the volume of the cone? Well, volume is given by 1/3 base area times height. Base area is given by area of the circle. So, Zheng Jie, what is the formula for area of this circle? What's the formula for area of a circle? You think one. Pi. I also, okay, what is the value of r? 5, very good. 5 square. So 1/3 base area already times height. at this moment do we have height? At this moment, do we have the height of the cone? Do you know where the height is? So B over here. Huh? This dotted line is our height. This is our perpendicular height. I need that value. How to find that value? Jermaine, how to find that value of H? Or do you need help? Help. Okay, help. What shape do you see? With that dotted line, what shape do you see? Uh, 2D shape. Must find that 2D shape. What's that 2D shape? Right angle, triangle. Do you see the right angle triangle? You see that, right? So right angle triangle, two things must come to mind. What are they? Pythagoras as well as trigo. Do we have any angles over here? No angles. We are interested in the distance only. That means we use Pythagoras. Pythagoras requires two distance in order to find the third distance. The third distance that I want to find is the value of H, correct? I want to find H, meaning I need the other two distance. How many distance do you have already? 1. What is that distance? 5 cm. So which other distance are you expected to be able to get? The slant height. Excellent. I like the way you say it. It is called the slant height. Do we know the slant height? It is not drawn in my diagram. But who is holding on to the paper now? Matthias, where's the slant height? Okay, can you hold it higher so that people can see? Where's the slant height? Where the two ends meet, right? Can you open it up again? What? So when you open it up, can you hold higher, stand up so that people can see? Okay, so when can you show us the slant height again? Okay, turn it around. Can you see where the two straight line meet? That is the slant height. Now you open it up again. What does that slant height correspond to in that semicircle, Jermaine? The radius of what? Correct. This slant height that you are interested in, height equals to this 10 cm. That was how the cone was formed. Okay, later the paper pass. Just now nobody want the paper. Now everybody want holding on to the paper. Pass the paper all the way back to Jermaine. It is our 10 cm. So with our hypotenuse as 10, with the base as 5, we can find the value of H very easily. I'm going to put it here. Square root 10 square minus 5 square. You should be able to understand this, Pythagoras theorem. So we can calculate the volume of the cone now. 100 minus 25, that's 75. Root it times 25 times pi divided by 3. 226.724. Round it off. 227 cubic centimeters. Is it in cm? Yes. Okay, so that was part A. Now part B. Here's I asked you to do some homework. Pi RL, is it? I asked you to find out why is it pi RL, is it? Oh yeah, okay. So anybody found what pi the curved surface area? Equals to pi RL, where L is the slant height, like what Jermaine mentioned just now. So pi, the radius is 5, and the value for the slant height is square root 75. So let's just get this done out of the way first. (136.03). Oh yes, ask why rectangle. Why is it a rectangle? Okay, anybody needs more time for this? Akila done? Not done yet. Is as such pi RL. L change for the L. Okay, so why did this person who created the node say area of rectangle? Where's the rectangle? Anybody knows where the rectangle is? Xuan, where's the rectangle? Remember, we are trying to find the area of the curved surface area. So what they did in this case was they split that curved surface area into many strips. Then they line up the strip, up, down, up, down, up, down, up, down. And then they form this shape. So why is it called a rectangle? Is it a rectangle? Anybody wants to try? Anybody help? Help, Xuan. Oh, you're really okay with just accepting formula like that? You're really okay with just parallel and don't want to know about it? But I cannot take it. I cannot, I must say. But I'm disappointed that you all don't want to know. You understand already? Okay, then can you tell us why? Where got two triangle? Where got triangle? Okay, when he said triangle, he's actually talking, you're actually talking about one of these strips, is it? Is it really a triangle? Is it a triangle? Oh, same logic. Okay, so he's approximating. He's not wrong. He's to be more exact, he's approximating this strip, which if I were to exaggerate, it looks like this, right? It is a curve at the bottom. He is approximating it to be a triangle, right? And then when he places two of them like this, he says that it is like a rectangle. Is that a point? Okay, but is it really like a rectangle? Or does it look more like a parallelogram to you? Kind of, right? It kind of looks more like a parallelogram, isn't it? It is like slanted over here. What? If you approximate this to be a triangle, then you should say it is approximately a parallelogram. Now, this, what I've just drawn is not an accurate representation of the situation over here where they cut into many, many strips. What I have done on the right-hand side is just two very fat strips, very wide. It is not a good representation. If I were to continue doing it my way, I'm going to end up with something like this. Doesn't really look like a rectangle. Looks more like a parallelogram. But the idea is that the area of all these will be the area of the curved surface area, right? That is the whole basis of this. Now, how do we make my diagram become more accurate, become a more accurate representation of the curved surface area of the cone? This is a very bad representation. This is a little better. Okay, what is printed in the notes is a little more accurate compared to what I did with just 1, 2, 3, 4, 5, 6 strips. So how is the notes better? They had more strips. They had more of them. The more strips you create, the more you cut, the more it becomes like the triangle that Samuel is saying. Because the more you cut, the shorter this distance is going to become. It is going to look less and less like a curve until it is so narrow, it is almost like a straight line. That happens when you cut into many, many strips. How fine should the strips be? 1 mm? That's good, right? Half an mm? Even better. How about 0.000001 mm? That'll be fantastic. The finer you cut, at the same time, the more this angle becomes 90 degrees, the more it becomes like a rectangle. So this word rectangle over here, area of rectangle, is describing the case where I cut this so many times such that it eventually becomes a rectangle. Sorry, okay, back. Okay, so that is how the formula was derived. And then why did we have pi r times L? Okay, then this part you can really figure it by yourself already, based on the diagram. The way they cut it, you can see for yourself visually the dimensions. Why the dimensions pi r? Sorry, on this side vertically it will be L, horizontally why is it pi r? That one you can figure out. But the important point over here is that the idea of cutting it into so many strips to form a rectangle, that is a very important concept that you need to know in Sec 4. Okay, but this is an introduction. Actually, when we learn area and volume, and surface area, we are using this very similar idea of adding strips continuously to form a volume, right? The volume of your water bottle, if it's a cylinder, you are actually adding areas and areas and areas of circle. You add them up such that you form a volume. If you are talking about the curved surface area of a cylinder, we are actually adding up circumference upon circumference like rubber bands. You're adding rubber band, rubber band, rubber band, rubber band, and then you form the curved surface area. What are we adding? We're adding circumference. Add. So this whole idea of adding things up infinitely, very important. Must understand. Next time, Sec 4. Okay, I say what I wanted to say. Okay, so chapter 10, part 2 again. Where will we? Okay, textbook questions. No, there's one more first. The O-level question. Okay, so here we've got a pencil made out of a cylinder and a cone. Cylinder radius 0.4, height 16, cone blah blah blah. Calculate slant height of the cone. So the cone, it'll be better if you draw it out by yourself again. Okay, so the vertical distance is 2. Then our diameter is 0.8, so our radius will be 0.4. Need to draw the right angle triangle. Now the slant height in this portion, we see a right angle triangle, Pythagoras theorem. So A part 1, slant height will be square root of 2 square plus 0.4 square. Okay, all in cm. 0.4. I say all in cm. So 4 plus 0.4 square. So we get 2.0396 cm. Round off the 3SF, 2.04 cm. That will be the slant height. So total surface area of the pencil. Can visualize where are the surface areas? How many surface areas do you see? If you want to break it down, the total surface area is made up of the curved surface area of the cone. That's one. We can find out pi r L. We've got the slant height already. We've got a curved surface area of the cylinder, which, like I mentioned just now, is like rubber band upon rubber band. So it is actually the circumference of each of these rubber band times this distance, which is 16. So circumference times 16 to get a curved surface area. And we've got one last area. The circle at the bottom, that's very sure. Easily calculated. So you can add all of them up. Find the total surface area. So that gives us 3 marks. Okay, I think I don't want to. I think you can do it by yourself. Okay, just are the answers given? Don't have. Okay, I'll upload it. I think you can do it by yourself. So next one. Volume of the pencil volume is made up of the cylinder. So the cylinder, the volume, like I said, the water, right? You're adding area upon area upon area. So area times the perpendicular distance. The area, which you have found out, times 16 again. Then the area of the cone, 1/3 base area times height. Okay, easily found for the volume of the pencil. So now they put a pencil into this box. Show. When they ask you to show, it is because they require this information, this value, to be used in the next part. Even if you can't show, just go ahead and use the value for part 2. So show that the volume inside the box is as such, requires us to find this distance, and this distance. 3 of them multiplied together to give you 138.24. Okay, so the distances also quite easily calculated. Here we've got 4 radius. You got the radius from over here already. So diameter 0.8 or 0.8 times 2, diameter times 2, same. So 1, 2, 3, 4, 5, 6. So this will be 6 diameter to get a volume. Then percentage of the volume that is not occupied by the pencil. So find the empty space. In part B, you have the volume of 1 pencil. What about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? 12 pencils, volume of 12 pencils equals to 12 times answer in part B. This is our answer in B. Once you get the volume of the 12 pencils, you can find the empty space very easily. Or actually, we can just run out of final answer already. Percentage volume will be our answer in part 1, 138.24 minus answer in part 2 divided by total space times 100%. And get the answer, round off. So this will be in percentages. Can? Okay, we don't really have time for our textbook question already. I'll just tell you what is your homework for today. But the homework question, we will go through only the ones that you need help with next lesson. So please go back and check. Maybe upload the question. I upload the solution. I'll upload the solution for the textbook question. You can check. Next lesson, we only go through those that you need help with. Need explanation. You have your 10 part 3 notes. Okay? So go and watch the video over here. Hey, no video. Yeah, I got. What's this? YouTube video. Okay, watch this. And follow the instructions. That's all. That's that. Thank you, class. Have a nice day. Geography paper. Good luck, good luck.